Okay, great. So today we're going to talk with Larry Peterson, who is a professor emeritus at Princeton University. He's also the chief architect at the Open Network Lab, and he's on the faculty at University of Arizona now. So we'll talk about NFV, its relationship to SDN, and OpenCloud, and all things related to that. So thanks, Larry.
Looking forward to it.
So, so yeah, I guess now in particular in your position with the Open Networking Lab, you're doing a lot with respect to OpenCloud, and I think it'll be fun to kind of talk about how you got there. But maybe we should start a little bit talking first about NFV. I think even just a year ago when I started teaching the course, NFV didn't, it barely existed, not, basically not even enough to talk about it. But now it's really taking off. So I think, can you talk a little bit about NFV? What are the kind of exciting things going on there, and how does it really relate to SDN?
Sure. So I think of NFV, Network Function Virtualization, as the telco carrier operator world trying to figure out how to leverage cloud technology. They buy purpose-built hardware appliances to do all kinds of functions, and they're looking to move that into virtual machines and take advantage of scaling those virtual machines, but out in the middle of their operator networks, not necessarily back in the data center. So, I mean, one way to look at it is SDN is about making the control plane programmable, and NFV is about making the data plane programmable. And that's all related to the cloud, because the cloud is about making whatever the function is, data plane, control plane application, scalable. And so I really see NFV as one of three legs of cloud, SDN, and NFV. There's a certain starting set of functions people talk about. It's exactly what they're buying appliances for at the edge right now. But I think it kind of generalizes, and it's hard to draw a line between what is a network function virtualization and what's a proxy and what was really a web service of a more general kind. So it did start. Started hearing about it a couple of years ago at first. It was just to trace a little bit of the history. I've been involved in Planet Lab now for about a decade, and that was really about creating new functions out in the middle of the network, the edge of the network, and running in virtual machines. And so we, in a sense, it was kind of like a cloud, except it wasn't locked in a data center. It was out at the edges. And as a consequence of that, we built some interesting functions. The research community did. But I was involved sort of in parallel with Planet Lab working on caching technology with Vivek Pai and others at Princeton. And that led to a CDN called Koblitz, which we then found that there was commercial interest for, and in particular carriers, network operators, wanted to install their own caches because they had their own content to deliver, and they were delivering content on behalf of external aggregators like Akamai. And so they had reason to install their own caches, and this is, in my view, the beginning of NFV in the sense that it was a point where technology that grew up in, let's call it the IT space, as distinct from the telco space, was really finding a reason for it in the edge of the telco space, and so there was a culture clash going on, where at the edge of the network, people tend to think in terms of devices. And here was suddenly a function or a service implemented in software, running in virtual machines, in fact. And so, I mean, there's an interesting backstory just about how distributed systems people look at the service-wide behavior, and networking telco people look at device behavior. But in any case, that was the first one of these kinds of functions that I'm aware of that was actually running in a virtual machine, being deployed at the edge of the network, at the edge of the telco network. And that sort of opens the door. Well, what else could we do here? So about now 2 years ago, and this is now literally the origins of the term NFV, there was a proof of concept pulled together by some people at BT and British Telecom. They were interested in primarily they were interested, I think, in reducing costs, but also in time to market. And so again, this is how do you take cloud technology, which has been working for the Googles of the world, can we make it work for us, and moving it out to the edge of the network. And there was a proof of concept pulled together that was involved them and Intel, who would of course interest in general good uses of Intel processors everywhere. HP as an integrator, and the company then that ultimately came out of this Koblitz exercise, which was called VeriView at the time. It's since become a part of Akamai. But that was an example of the first NFV, the first network function. We ran it side by side with BRAS, which is the subscriber endpoint for the BT network. And we were running on Blade servers, and we had virtual machines, and we had these two functions co-located together. BT was interested in that being much more than a BT-only endeavor, and so did a lot of good work to bring in the community and to create what's now a working group exploring a network function virtualization. But the summary of the story is it was a cloudish, scalable technology that was brought out to the edge of the network, and that really, I think, is what the telcos are looking for to move away from hardware appliances into virtualized appliances.
Are there specific vendors or specific pieces of hardware? Like, I mean, obviously there are pieces of hardware that can be displaced by this technology, but is this a space where there are completely new people moving in now and serving the telco's needs?
Yeah, I think that's the hope, that there becomes an app store for telco services. That's not yet happened. It's a slightly different place than thinking about apps in the cloud, because when you deploy an app in the cloud, you deploy your app and you manage it, and I deploy my app and I manage it or operate it. In the telco space, the telco is the operator. They operate the services. So they want to pick up third-party services, deploy them, and then operate them. And then they, of course, don't want stovepiped operations, because that's not going to scale very well. So they're looking for a way to integrate. And so integration still becomes a pretty important thing here. And so the obvious players are building service orchestration mechanisms that sort of, that will become the Android or the iOS equivalent at some point. But what's happening is that the current hardware vendors, and now not necessarily talking about the Ciscos and Junipers, but you get to people that build firewalls and deep packet inspection and more narrowly defined functions. They're all under pressure, I think, to redo the licensing so that you can license the software from them. And they're all making that move right now, I think.
So it seems to me like, I mean, I guess I'd always sort of thought about NFV in terms of just sort of like Middlebox orchestration more generally. I'd never really realized that it's actually just, I mean, at least as you're describing it, a pretty telco centric kind of view. Do you think it's more broad than that, or do you think that's just where the origins lie?
Well, yeah, I think that's the origin, and I don't think that's where the telcos will stop. I think that's where they're starting, and to me, even a narrow definition of Middlebox and these network functions at the edge are still pretty similar. One's a little bit more enterprise-oriented, maybe one's more consumer residential-oriented, but they're still of the same sort as I see it. I think where you start to do something more importantly different is when you start blurring the line between these things at the edge of the network and what's back in the data center. And now you start throwing into the mix all of the services you might find at Amazon or Google, and a not clear demarcation point between what is the over-the-top service offered from the data center that goes over the carrier's network versus what is more deeply integrated and embedded in the carrier's network. And it's clearly yet to be seen that the telcos are going to compete with the cloud providers, but I think because of their footprint, they have an opportunity to do something interesting there.
Yeah, I mean that seems like a really interesting tug of war. I guess having focused mainly on networking myself, I sort of pay attention to the current tug of war that's going on with performance and provisioning as far as what's between the cloud providers and the carriers. But I hadn't realized that there was also this tug of war going on with like who should basically own or control different services in the network. I could see one particular example there being like video transcoding. I mean, is that a real example? I mean, like
I think video is yeah. Yeah, video is clearly one of the driving. I mean, you could go back to the caching story, which is it's video that led to the need for caching, which led to putting these virtual machines at the edge of the network in the first place. So that is certainly one of the drivers. And I obviously can't speak for the carriers. I'm just saying that there is an opportunity. So moving into the technical realm a little bit from the where the market's going. I think where NFV starts is actually a fairly narrow place, which is I used to have a hardware appliance. It's now a VM. What do I do with the VM? Well, I manage it the same way I manage my hardware appliances, which I kind of bump and wire string them together. That I think is a big mistake. If you want to really take advantage of the cloud, then you need to think about scalability, and you don't scale bump in the wire quite the way that they're thinking about it. It's not. It shouldn't be, we're virtualizing a function and now I've got one of them I string together linearly. Each one of those functions is in fact itself a scalable service. And so now it becomes about service composition. Each service independently scales to 1 to 1,000 virtual machines. Those virtual machines, some of them are located at the edge of the network and some of them are back in the data center depending on exactly how they're participating in the function. And these services interact with each other, and that interaction is itself much more complicated than a linear service stream or function streaming or whatever they want to, service streaming I guess it's called, or chaining.
Right. Yeah, I keep hearing this term too, service chaining, right? That's another thing that's sort of like come up recently, I guess, in the past year or two.
And I think service chaining is the metaphor that you use when you still are truly embedded in the hardware world and you haven't yet fully come to grips with the fact that these functions are running in the cloud. And
so you think that the right way to think about it is not like a linear chaining of services, but like thinking about different ways to compose or different ways to sort of
right. So service composition I think is where this takes you, and there will be some cases that it's fairly linear or sequential, but you move up the stack an inch, and the interactions become much more complicated. It's not just packet in, packet out. I'm doing DNS requests and I'm getting responses back. I'm doing HTTP requests, some of which are cached, some of which are forwarded on. I go to a database to look up some metadata. I mean, it's a lot of interaction between these various, and I'm going to call them services instead of functions because and by that I'm just implying that it's the function scaled in some number of virtual machines. And then once you do that, it's not just, and this will bring it back to SDN, it's not just about the virtual machines running the function, it's about how they're connected together in the network. And once you move away from a simple service chaining model where implicitly it's linear, then there are virtual networks involved. And where did those virtual networks come from? They came from the SDN control. So I think these things all tie together, that the model that I believe is the right one, at least as of now, is I start with, well, I'm going to call it a slice because that's the language we used from Planet Lab. But a slice on Planet Lab was just a set of virtual machines, and coincidentally they were connected by the internet. Now a slice is a set of virtual machines and a set of one or more virtual networks. And by virtual network, I don't mean VPN, I mean the kind of virtual network I could get out of a network hypervisor. And why do I need more than one virtual network? Well, now that is actually really a critical part of what the operators need. If you go into the cloud, it might be sufficient to have a private network that my VMs talk to each other on, and a public interface that I talk to my clients on, or the subscribers to the service. But when you embed this function or this service in a telco, then there is a real strong desire for adhering to the principle of least privilege. And so they are very, very careful about this service can talk to that service, but it can't talk to this other one, and this particular service doesn't have a public-facing interface. And so now the virtual networks become a really critical tool in isolating functions, as is the case in a multi-tenant cloud. But you also need to allow these virtual networks to compose with each other in some way if service A is going to be able to talk to service B. And that's really, I think, the new requirement on SDN that comes out of this.
And that composition is going to look different than extranets or whatever we had in the past, where there were sort of like VPNs with sort of limited connectivity between each other. You think it's like just a totally different set of functions that we're going to need?
Well, I think the jury's still out a little bit on that, but first of all, they need to be composed. So by definition, virtual networks are isolated. Now,
Hmm.
how do I let virtual machines on my virtual network talk to virtual machines on your virtual network if they need to talk to each other? Um, well, I mean, there are different approaches to this. You could declare there to be virtual networks that multiple services VMs share, sort of a common virtual network. Another possibility that I think is kind of intriguing is if you're implementing your virtual networks on top of a network hypervisor, and I'm using that term as one of the layers in the SDN stack, then that hypervisor is aware of the existence of multiple virtual networks. If you sort of take a metaphor from virtual machine hypervisors, uh, we sometimes talk about domain zero as the super user or extra privileged domain that sits adjacent to all the other virtual machines. Well, there's a domain zero equivalent in network hypervisor world, and one could use it to teleport from one virtual network to another. And the interesting thing is that's a real performance problem in server world because you get the trampoline effect. I jump up into domain zero, then I jump back down, and I got all these kernel crossings going on. But if your network hypervisor is implemented on top of the physical network and implements the virtual networks using OpenFlow, then it's a simple matter of getting the OpenFlow rules right so that data can move from one virtual network to another. So I've just gone down a bit of a rat hole there in terms of an implementation approach. But the takeaway is virtual networks are extremely powerful. I think they are going to be the cornerstone of composition between these services. We understand them to give us isolation. I think with a little work, we can also use them as a very controlled way of interconnecting services and the slices they run in. And that, I think, is going to be a critical differentiator with how network functions are deployed throughout networks as opposed to what we're currently doing with virtual machines in the data center. Maybe I'm just ignorant of all the ways virtual machines are being configured in the data center, but I think there's a fundamentally different thing going on here because of composition.
It seems like there's maybe space for sort of developing interesting ways to control like what kinds of information can move between one virtual network and another. I mean, we don't really have those kinds of primitives exactly.
That's right. That's right. Yeah.
Right. I mean, that seems like a really interesting sort of security problem or something.
Right. And now, right, so there are some really interesting research problems that come out of this. So I think the way that I'm thinking about it is I like the idea that services are first-class objects in my system. You mentioned OpenCloud, and that's kind of the cornerstone principle: is that everything's a service is the key idea there. And I want to be able to control my service, and I view the way my service interacts with your service, and certainly they're both being mapped onto the same underlying hardware. Our virtual machines may or may not be co-located, our virtual networks may or may not flow through the same physical switches, but how you get that right is an optimization. There is an opportunity to do a nice job of specification, and then it's job of agents like this network hypervisor that will map that onto the physical machines and the physical networks. And that's where all the hard optimization problems will come in. I think the mistake a lot of people are doing is once you move away from drawing simple sequential bump in the wire service chaining, the next thing you do is you start drawing some completely impossible to parse diagrams with all the flows of packets between the virtual machines deployed in your network, and there's no way any human could get that right. I think you start with some simple abstractions like services run in slices. Slices are a set of virtual machines connected by virtual networks. There is a problem of virtual machine placement that's completely service specific. Is it at the edge? Is it at the data center? Is it both? And virtual network topology. Is a big switch? Is it a hierarchy? Might be appropriate for something like a CDN. And then as I start interacting with other services, I may have to accommodate that may pose performance behavior on me that I have to account for somehow and adjust. And there's the opportunity for some global optimization probably too.
Yeah, it seems. I mean, I've thought about it a little bit myself. I just had a pretty tough time just getting my head around some of the optimization problems. It seems like, I mean, you brought up several things. I mean, one is sort of security related, where who should be able to talk to whom and in what scenarios and for what flows. But I think another thing you mentioned is sort of things that relate to traffic load, right? I mean, you could take sort of a you know simple load balancer example and you say, okay, well, should I have these devices like closer to the middle of the network, or should I move them? Should I have sort of more lightweight ones closer to the edge? And there's a load question there. Another one that I've heard that come up is, firewall placement, right? Like, or other kinds of middle box placement where, okay, well, if you move it close to the core, you've got to put more rules. If you move it close to the edge, you can do other things, and
Yeah, yeah,
that has implications for maintenance. And
yeah,
um,
yeah.
go ahead. I mean,
Well,
whatever you want to say about
you
that,
actually
great.
raised two very interesting examples that I think throw a really interesting angle on this problem, which is load balancing and firewalls. Right? It turns out that in different ways you can implement those in open flow controlled switches. So suddenly there's another element here, which is you've got the virtual networks, you've got the virtual machines, and you've got the controllers of the virtual networks. And so I may construct a virtual network that does my load balancing for me by running an SDN application on that network. Or a firewall is sort of the canonical example of I program the network to be my firewall, not a firewall device. I seem to have lost you.